Hi, my name is Mackenzie Ferguson, and I am a rising junior at Bucknell University. I am studying civil engineering, and my research this summer is mentored by Professor Newland. The topic of my research is transient storage zones and civil infrastructure interactions in local streams in the Buffalo Creek watershed in Pennsylvania. Transient storage zones are small pockets of slow-moving water that interact with solutes and impact water quality in the surrounding ecosystem. However, modern infrastructure has changed how streams naturally flow because now there are various forms of bridges and culverts used to prevent streams from flooding roadways. This infrastructure can change flow patterns in the main channel and impact the processes in transient storage zones. In addition, civil infrastructure creates impervious surfaces near stream systems. Therefore, the presence of infrastructure can create substantial discontinuity in a stream. The specific research question that we focus on is the impact of civil infrastructure, such as bridge crossings, culverts, and other land use changes on transient storage zone characteristics and processes. We used ArcGIS mapping and data analysis for an initial investigation of the extent of infrastructure impacts on streams. Further research approaches are discussed that could help to determine how the presence of infrastructure impacts the stream processes in more detail. When infrastructure is built, most of the surrounding land is cleared so there can be room to work and enough room for high flows of water to pass under. This impacts the flow and creates storage zones, which is why land cover information in the stream buffer zone is important. In the Buffalo Creek watershed, 69.2% of the 100-foot buffer zone is made up of tree canopy, which is good because trees help prevent bank erosion. ArcGIS Pro is a computer program that can be used to explore, visualize, and analyze data. I used ArcGIS to identify where streams and bridges intersect on a map, and then added bridge and culvert data and marked the intersections that were missing data. Accounting for all of the intersections, the bridge width average and PennDOT right-of-way standard of 33 feet were used to find the impacted stream length and compared to the total stream length to find that 2.13% of the stream length is impacted by civil infrastructure. To conclude, civil infrastructure in streams such as bridges and culverts impact the natural flow of streams and disrupt the surface-subsurface water interactions. The ArcGIS analysis can give us an estimate of the extent of this impact of civil infrastructure on transient storage processes in streams.